Um, so I'm just gonna scroll through and see if there are questions based on what we're doing. Oh, no. So, actually, Koto, can I ask you, how many questions have you done on longitudinal waves? Have you done questions based on sound?
At school,
Yeah, it's cool.
I didn't feel, I'm not sure because we do it in our workbook.
Uh, um, so actually, the thing about longitudinal waves is that you're gonna have to deal with these two. You're gonna have to deal with sound, and you're gonna have to deal with EM radiation. So, are you guys finished with waves? Like completely finished with waves?
Yes.
Okay, so I guess we'll just have to continue. So this is a question that's actually based on sound. And this one is still based on the same thing we were doing. So let's actually just do this one first. They say different types of EM radiation have different frequencies. This can influence their properties, which could be used, and what each could be used for in our daily lives. So they want you to match the frequency and the EM radiation. So do you remember the table, the previous table that we had?
Yeah.
So can you try to like match these? Let's say which frequency can you match ultraviolet with? You can just say A, B, or C. That's fine.
Um, is ultraviolet C?
Yeah. Ultraviolet is C. And can you try gamma?
Is gamma A?
Yes, gamma is A. Oh, why does this line look weird? And obviously radio is gonna be B. So that was actually great. So at least like now you understand the frequencies and stuff. What's this thing? What's this thing? I'm just gonna erase this again, and yeah, I'll actually just draw with this one. So they say write down each of the following types of radiation. Oh yeah, sorry, one use of each of the following types of radiation. So I'm pretty sure I did explain to you what infrared rays are for and what microwaves are for. So I think we can just skip this one, right?
Yeah.
Then when they say when a doctor needs to establish the seriousness of a fracture, a picture is taken of the broken bone. The picture below shows the fracture. And they say name the type of radiation that's used to take this type of picture. Can you try it?
X-rays.
Exactly. So obviously it's gonna be an X-ray. And they say properties of this type of radiation, which enables it to perform this procedure. So actually what happens now is that when they start asking you for properties, you can just say the danger of overexposure. So the property of an X-ray is that which words can I use? You know what? Let me just search it because I which words can I use? Property of X-ray to penetrate through skin. They say the X-ray beam travels through the air and comes in contact with the body tissues and produces an image of a metal film. Soft tissue like organs and skin cannot absorb this high energy rays, and the beam passes through them. Dense material in our bodies, like bones, absorb this radiation, and that's why we can see our bones, because the bones absorb the radiation of the X-ray. But since our skin and organs cannot absorb that radiation, we cannot see our skin using an X-ray. So I think that's actually a very nice explanation. As they say, the danger of overexposure to this type of radiation, usually when they ask you about the danger of overexposure, it's usually gonna have to be something to do with cancer, because even though all these radiations might be helpful, they're still harmful to the human body for if you expose yourself for a longer period of time. So X-rays can also cause cancer. That's why it's dangerous for you to be scanning a pregnant woman or a baby. So it's that's the main danger of overexposure to the radiation, is you're risking cancer. They say a radio program is transmitted in the FM band, and it has a wavelength of 3 meters. They want you to calculate the energy of the photon of the radio wave. So I'm gonna I'm gonna show you another equation which is used for this. So you know that energy is equal to Planck's constant multiplied by the frequency. I think this looks better. And then you also, from our previous question, you know that frequency is equal to c divided by the wavelength. C being the speed of light, and obviously our wavelength here is given in 3 meters. So Planck's constant is actually will always be in your question paper. Let me just show it to you right now. This is Planck's constant. You see it's 6.63 times 10 to the exponent 34. So what you can do is that you can replace this C with this. So you're gonna end up with something along the lines of E is equal to H C over the wavelength. So you're gonna end up with 6.64 times 10 to the exponent negative 34. This is, and our speed of light, which is 3 times 10 to the exponent 8, divided by our 3 meters. And this is gonna give us, what's my calculator? 6.64 times 10 to the exponent, which is 34. If you want, you can just put this in brackets. And your answer is gonna be 6.64 times 10 to the exponent negative 26 joules. And that's your answer for 8.4. So far, do you think you're getting the hang of like EM radiation, or do you want to do more and more questions?
I'm getting the hang of it.
Okay, okay. So that's
Is
sorry.
the lost answer? I didn't write it out. Please.
Okay.
Thank you, Dad.
Okay. So after this, what this the other thing that you're gonna have to know is the sound portion of longitudinal waves. And for sound, think do they still give you guys the speed of sound? Um, so just know that the speed of sound varies depending on the medium. So there's the speed of sound in water, there's the speed of sound in air, and there's it's like different speeds onwards. So I think if I remember well, the speed of sound, let's look at this experiment. They say a band decides to experiment with sound during a practice sessions. The diagram below indicates the musician playing specific notes. The guitar is plugged into a speaker to amplify the sound. And they say a microphone is connected to an oscilloscope so that the frequency of the sound can be measured. And they say below the table represents the data of the notes being played. So you can see that each note has a different wavelength and has a different frequency to it. And then they want you to write down the independent variable. So the independent variable is the one that will never change regardless of, okay, the independent variable is the one that causes change on the dependent variable. So most of the time when you're gonna have like your graph, your independent variable is gonna be on your x, and your dependent variable is gonna be on your y. So in this particular case, what can I say is independent? In this particular case, I can say the wavelength of the node is independent, and the frequency changes with the wavelength of the node. So I don't know if I gave you a good explanation, but the wavelength is actually the frequency actually changes because of the wavelength, and the wavelength does not change because of the frequency. Do you understand that? I don't know if it's the right terminology
I
or
understand.
okay. So here the wavelength is gonna be independent, and the frequency is gonna be dependent, and this is gonna be the control. This is gonna be the controlled variable. Sorry. So this is gonna be the control, and they say draw a graph of the data plotting by plotting the frequency on the y versus the wavelength, which is going to be on the x. So if you can look at this, it's like a bit of mind games, because you remember what I said? I said the independent is usually on the x and the dependent is usually on the y. So now if you look at it, the independent was the wavelength and the dependent was the frequency. And if you look at it here, they want the frequency on the y and the wavelength on the x. So if you do if if you do meet this type of question, you can just look through all the questions at once. So maybe you can know, so maybe you can get some answers to the previous question by looking at the next question, or some clues. Let's just say clues, because I don't think it's like it's answers. So yeah, now we're gonna try to draw the graph. So basically the graph is just gonna be the same thing. You're just gonna write this, that, and you're gonna start plotting, which is frequency is increasing, going upward, and the wavelength is increasing, going to the left. So when you're gonna draw your graph, this is sort of like a simplified version. So I'm gonna tell you the things that you need to do when you're drawing a graph in science. So the first thing you must do is you must have a title. So up here you must have the title of the graph, whatever versus whatever, graph indicating the frequency versus the wavelength, or graph indicating the wavelength versus the frequency. But it's usually graph indicating y versus x. And then after that, you're gonna draw your x's and you're gonna show that this is y positive going up, and this is x, positive going to the right. And you're gonna label them. Let's say I'm just gonna use f for frequency. You're just gonna say frequency, and you're gonna put the units in the brackets, hertz, and here you're gonna say wavelength, and in brackets you're gonna say meters. Those are all the things you have to do before you actually start putting in your points in here. So 3, 6, 12, 3, 6, 9, 12, what. So as you can see, the frequency decreases as the wavelength increases. So it's gonna look something along these lines. And this is gonna be the graph that you draw for 7.3. I don't know. I'll just screenshot this and send it to you so you can try it for yourself and see if you can get the graph looking like this. If it doesn't look like this, you can still just ask me any questions in the WhatsApp group. So they say use the graph to determine the mathematical relationship between frequency and wavelength. What you can say is that frequency is indirectly proportional to wavelength, or wavelength is indirectly proportional to frequency. Whenever they ask you for the mathematical relationship, and you can see it's a 1 mark question, you have to say either this thing is directly or indirectly proportional. If something is directly proportional, if some two things are directly proportional, the graph is gonna look something like this. As this one is increasing, this other one will also increase. So the graph is gonna look something along these lines, or something like this. They just both increase, but since you can see that this graph is something like this, it's as the frequency, as the wavelength increases, the frequency goes down. This shows that there's an indirect relationship between the two. So they're indirectly proportional. This is directly proportional. This is indirectly proportional. So do you understand that?
Yes.
Okay. So they say use the information for node X to determine the speed of the sound. So we're just gonna look at node X. So X has a wavelength of 6 meters and a frequency of 55. From your calculations using transverse waves, you know V is equal to uh, wavelength multiplied by the frequency, which is gonna be equal to 6 multiplied by 55, which is gonna give you, let me just calculate this first. I think it's somewhere around 340, I'm not sure, or 330, 6 multiplied by 55, 330 meters per second. So that's your answer for 7.5. So you can see like even solving for sound, it's easy. It's the same equations over and over again. You just need to know just a few more details about the concept. But the equations are the same. So are you fine with this now? So you can hear me?
Excuse me, what did you say?
Now I'm just asking if you understand so far because
Yes.
okay. So after doing all those questions, do you have anything you can ask?
No, not now.
Mm. Oh yeah, let me just quickly go through that picture that you sent me because I wanna know what else I have to teach you for. But I actually think that this is a relevant amount of information, and I don't want to bombard you with too much information because um how about on Tuesday on you said we're gonna meet on Tuesday, right?
Excuse me?
You said we're gonna meet on Tuesday.
Oh, yes.
Okay. So should I send these questions to you for you to try it by yourself? Because
Yes, please.
okay. Let me just what's that picture? To just do your messages do your messages still automatically delete themselves? Okay. Waves, electricity and magnetism, electrostatics, and electric circuits. So you know what we can do? Uh, since this website is down, this website literally has all the question papers. So, no. So can I just send you the questions and you just do them and then I'll just wait for this thing to go back up and then on Tuesday we can get started with uh electro electrostatics.
Yes.
Okay, how many weeks is this? Tuesday, uh 1, 2, 3, 4. So we have 4 weeks. We need to get started on electrostatics and electricity as soon as possible. So yeah, I'll just send you these. If this website does load, I'll send you these, and then we can have another meeting on Monday. If if you have questions, please don't be afraid to ask me questions because we no longer have that much time. We only have, I can say, 8 lessons before you write your exam. So please don't be afraid to ask me questions. So yeah, I think if you don't have any questions, I think we can stop. Do you have any?
No.
Okay, so yeah, enjoy your Saturday, enjoy your weekend, and hopefully I'll see you on Monday. But if not on Monday, I'll see you Tuesday during our lesson. Okay, goodbye.
Okay. Bye. Are we not having a double lesson?
Nah, that's actually the problem is that this thing won't open. This is why I get all
Oh,
my question papers, and I don't have any of them offline, unfortunately. Sorry.
oh, good. It's fine.
Bye.
Bye. Have you too. Bye.
Bye.
Thank you.